All right, so what we're going to learn in this module is we're going to get a little bit more into the code, and we're going to learn about unit testing. And when I teach coding, I don't tend to, I teach the unit testing first and just the basic concepts, and then we're going to expand upon actually writing code. So there might be some things that you don't understand, but really the objective of this module is to basically get you to be able to set up um, to understand what unit testing is, and through the hands-on, what we want to do is be able to create a Visual Studio solution that includes an application, a library, and testing for that library through unit tests. And in order to do this, we have to be very careful with how we set up the project so that we don't run into any funny problems. Because we pretty much have to set up a folder structure before we start to build set up the project in Visual Studio, which we'll get to in a little bit. So basically the focus of what we're doing is we're building a dynamic link library, our DLL. And so our DLL is going to be initially very, very simple, and it is going to just print a line out, basically just to replicate the same functionality that we have in the default command line application that you have. In this project, we're not going to worry about Docker too much. We'll bring Docker back later. We don't need Docker at the moment. And essentially, what you're going to see is that we're going to have an application. That application is going to have be the actual thing that executes. The library is what's going to do all the work, and then because the library is what does all the work, that's where we're going to have our unit testing. And what we're doing is that we have to understand that there's basically two types of tests. We have manual testing and we have automated testing. Manual testing is whenever you get a person, a human being, to actually click on buttons, type things into a console. Even you as a developer are doing manual testing if you're reading print lines and reading things out for yourself and typing input in every time you run your program. Manual testing is tedious and error prone, and it really slows down development. So we want to try to, as much as possible, get away from manual testing. And really what I look at is what is the cost benefit of manual testing versus automated testing, except in only certain situations like verifying that a user interface looks a certain way, or in certain exceptions it becomes more difficult to develop automated testing. But in most cases, technology exists for having automated testing for just about everything. So as much as you can, you want to develop your capabilities to implement automating testing at different levels. So there are different types of testing, just to understand this. You can read more about this at the types of in the reading for the unit, but basically we're focused on unit testing. And unit testing is testing at the lowest level of the program. It's testing each function's input, processing, and output. So each function you write, it's going to have a unit test. Okay, and we will contrast that with like integration testing, which is really testing whenever we put libraries together, like other people's code together, or other groups of code. We might test one or more libraries at the same time when they get put together, or integrated or merged. We might test systems, which is testing the whole application if it has maybe it has multiple parts. And so there's just different types of testing. And some of these testing, it's like usability testing really is difficult. Like if you look at non-functional testing, is something that maybe you can't automate. Um, or testing and applications uh, localization might be difficult, or compliance testing. Some things, different types of testing might be more difficult than others, but in most cases, I think you can set up automation for this. Now, we're going to talk about the benefits of unit testing, and these really extend to all types of testing, but really unit testing is the foundation of it. So unit testing helps to make our processes agile. So this is a cornerstone of agile development because unit tests allow us to change our code and develop it and make sure that whatever we made, whatever worked before for our end users or other developers that use our library continues to work. So if you want to do agile development, you really have to have good unit testing and understand it. Unit testing improves the quality of our code because it allows us to refactor it without fear of it breaking functionality that end users are using. It helps us find software bugs early. Maybe when we wrote something, we didn't see any bugs, but we go from .NET 3.0 core to .NET 4.0 core, and whenever we are running our unit tests, it will discover that the upgrade from 3 to 4 causes problems. Again, this kind of goes back to the agile thing, but this is going to facilitate changes to our code base and simplifies the integration with other code because we know that what we wrote works. So this kind of goes into also collaboration, that when one developer is working on something and another developer has to use their code or has to merge their code, by having good unit testing throughout the program, we can be assured whenever we merge code together that the program continues to work. I find that unit testing also helps to provide documentation because if you look at the unit testing, you can understand what your program's doing. It improves the debugging process because it can give us more insight into actually where problems are coming up. And it makes debugging faster because we're not typing in input or making selections manually. Those selections are being done in our testing. It helps us design our code because we're able to get a solution out quickly, but then go back that maybe meets a requirement, but then go back and redesign the code to make it more efficient, but ensuring that the improvements to the efficiency or design of our code or reusability of our code doesn't break existing functionality. And finally, all these combine to really reduce the cost of our development of our application in the long run, because the application that we are building needs to work. First of all, code that doesn't fulfill its end goal for its users really isn't worth anything. So one, it ensures that our project is worthwhile and continues to be worth it to our users. And also it reduces cost because what you'll see is because we're able to use our unit testing to automate testing, we don't spend so much time manually inspecting things because we know through our automated tests that things continue to work. And we also reduce costs because we reduce the chances, we reduce the number of errors that get into a production application, and overall it helps to make the project just more cost effective and successful. Now, we also here have to understand that testing, automated testing, really is the cornerstone of DevOps. And DevOps relies on automated testing to enable an agile development process, because really with DevOps what we're doing is we're going from the developer's development and we're then running automated tests, and we're trying to automate the integration of code from one branch to another and the merging, and we are trying to speed up that process through DevOps by automating things. And the only way we can do that is if we make sure we have ways that code can check code, so to speak, and that's the purpose of DevOps. So just to kind of re-say that is that the DevOps relies on automated testing to enable an agile development process. If you don't have automated testing, the idea of DevOps really doesn't work, because you need to have automated testing as the quality control that makes sure that what the developers implement is actually what is working whenever it gets deployed. Because if you have to have, every time you have to have manual intervention to check something, that's slowing down the deployment process and fixing process and development process for the application. So unit testing, really what we have is, it's really like testing one function. It uses what you're going to see is assertions, which it basically says that a piece of code completes a particular task and checks the input, basically the expected output. You assert that the expected output is correct, and you'll see this if that doesn't make sense. So basically assertions just say this output has to be match something or be something that you expect. And sometimes you'll see expecting or assert for different things, but just to imagine that they're just saying that this has to be the way I'm expecting, like I'm saying that this has to be the way it has to be for what is going in and what's coming out of a function, or what I'm expecting to come out of a function. Now, we're not going to get too into this right now because we're just getting into understanding unit testing, but once you get better at unit testing, you might want to look into test-driven development, or TDD, where you would write a test, the test fails, the error will come up, you'll see what it is, you write enough code to make the test pass, and then you refactor your code from the previous step. And it's a good idea to take a look at the article that I have here about C# and automated testing in the readings. Now, one thing I want to mention is testing and collaboration. So we'll see this a little bit more often as we progress through the course, but basically imagine that if you have multiple people working with the version control on a project, like more than one developer, not all developers are working on the same part of the application, and they may not know anything about what the other developers' tasks are. So in order to make sure that the application continues to run, a workflow for a developer might look at something like this. So developer A writes code and tests. Before the developer pushes, they pull the most current branch, they run their tests against the branch, and if there's any errors, they'll fix them. And then what they'll do is push their feature branch up to GitHub or to the version control system remote. When developer A pushes their feature branch and tests, they submit a pull request or notify another developer that's in charge of merging their code, or there's a continuous integration server that does this. Developer B would pull developer A's feature branch and merge it to a local development branch, and then run the automated test for the entire application on it. Once all of the automated tests pass, then they would merge the code and push it up to the development branch that all of the other developers would be pulling from. And so basically the idea is that as a developer in a team, you want to make sure that you have the most current version of the development branch that you're working on. Then you implement your feature with tests, then make sure that branch is up to date before you finally push it, and that your tests pass. Then the other developer would, or your supervisor or the senior developer or whoever else would pull that feature down, and then they're going to run the test on a local branch to check that everything is working. And if everything works, then they can merge it into the development branch or the master branch, depending on what branch is being used by people, and then the work can continue. So version control and unit testing really go hand in hand to make sure that people that are working together don't break each other's code as they're doing development. Now, in our hands-on, what we're going to do is we're going to look at AAA unit testing. So AAA is an acronym for arrange, act, and assert. So arrange, and what we can see here is, I'm going to pull up a little bit of code here. Just to take a look at this, and this is in the readings, but it's just really small. And so what we're going to see here is that arranging the test is here. We're basically, we want to test new class, and we are going to have a result variable to store our results. So we're arranging the test setup right here. Then we perform the action, which is what we want to test, and then we do the assertion like we were talking about, and we say assert that true is equal to result. Okay, so result true should be returned and saved into result, and then if true is returned, then this test pass. If it is not returned, if something else other than true, like false, is returned, then the test would fail. So just remember AAA, arrange, act, assert. And what we're going to do now is we're going to set up a project that is sort of like a template for what we're going to be doing in the future. So let's begin, and we're going to start up Visual Studio. But before we do that, we have to set up our project structure. So what I'm going to do is, I have a folder here for Visual Studio, and what I'm going to do is make a module 2 A, and I already have this done with module 2. So what we're going to need to do is, and we can take a look at this, is I'm going to fire up a new instance of Visual Studio, and I'm going to create a new project here. And what we got to understand is that we have solutions and projects. So solutions are collections of projects for Visual Studio. And since we're going to end up making a console app, what I'm going to do is I'm just going to start up and add the console app project first. So I'm going to change the location here. So I got to go to my Smart Zambia, and then I'm going to go to my Visual Studio folder, and I'm going to choose module 2A. I'm going to select this folder as where I'm going to store my solution. Okay. And then inside here, I'm going to have my project name. oops, I'm going to change this a little bit so I can actually just go and put it in Visual Studio, and I'm going to call it module 2A, and this is going to be the console app, and let's see if it lets me just stick it inside there. And the reason why we have to be careful with how we do this is because we want to make sure that our version control system is able to track everything for our tests and our application in this case. So here, if we look at the folder, we have the module, this is the solution, and then here is the console app application. All right. And what I'm going to do here is we're going to take the program open. We got the program open, and I'm going to just run the console app right now just to see what it does. So we have seen this before. We got hello world, and that's what we're going to try to get this thing to do, but with a library and testing. The next thing that we're going to do is come over here, and in the solution, I'm just going to, because I'm going to get ready for Git, I'm going to add a new item, and I'm just going to add a readme.md. And I'm going to add this, and I'm just going to say my first unit test application. And we can save this, and then what I can do is come down here and we can see that this README file is inside our solution, not inside of our application. Now sometimes you might want to have projects that are totally separate, but in this case we're going to put everything together in one folder. Alright, so if I go back to a program here, we're going to add this to source control in a minute, but we're going to get the basic structure of our application to work. So we're going to add a new project, and what we're going to do now is we're going to add a .NET Core class library. So we can actually just see this. So if we want to go C#, and we can see .NET Standard, .NET Core, we can actually limit there, but we want a .NET Core because we want everything .NET Core, so we can end up making this work on multiple platforms. And we're going to call this console utilities, and we're going to make sure we store it in our module, the solution folder here, which will come up here, and I'm going to create it. And it's going to come up and add our class file here, which we'll get into in a minute. And then what I'm going to do is I'm going to right click again, and then I'm going to add a new project, and you can look up, but you can find an MS test project.NET Core, and then we're going to do a console can say unit tests, console utilities, and we're going to create this. And what I'm going to do here is actually I'm just going to get rid of this unit test right here file because we don't want it. We just want the project. And then here I'm going to open up the class folder and I'm actually going to rename it, and I'm going to call this class utilities. Or let's just call it, yeah, let's just call it utilities. Okay, so this is basically how we have, and in the module we have here, just to show you, we have all this in here. So the whole thing is basically set up. It's a little slightly different than what I'm doing right now, but it's the same project. All right, so right now we are saying hello world, but we want to get rid of this and use we want to make a DLL and put it and use that instead of having out of our console utilities and use that. So what I'm going to do here is I'm going to go down to utilities, and what I'm going to do is do something, put a really simple public string, because I'm going to return a string data type, and I'm going to do, my function is going to be called write line, and I'm going to put in a string, and I'm going to name my variable string text, and then I'll put this and get the underline because it wants me to return something, so I'm just going to throw the return on it so it gets happy. And then what we're going to do is put a string, return that what was passed in, and let's go and make a test for this. Okay, so we're going to make a really simple test. We're not going to actually write anything to the console. So what I'm going to do here is I'm going to right click on the method. I'm going to go to create unit test, and here what I'll do is I'm going to put an empty body, and I'm going to stick the test in unit test console utilities. I don't want to add another project. That's important because we want to make sure it goes into the folder that is in for the whole project and not put a project folder someplace else. So once we're done with that, we're going to click OK. And we have our test method. So these are attributes. So if you look at they're included in one of the readings is the, where is it? Is this cheat sheet that talks all about testing. Okay, so a bunch of different testing methods and It's pretty useful to look at. This is using NuGet testing, which is a different library, but this helps with MS tests because there's different test frameworks that you can have. So right now we're just working with the MS test framework. So let's take a look at how we're going to get this to work. So what I'm going to do is first, if we remember our AAA, so we're going to arrange the test. So what we're going to do is we're going to say our I'm going to do utilities, put a variable equals new utilities. Then what we're going to do next is to arrange the test. We're going to want to set up a input, so a string and we can call it string input text equals, and it's exactly what we have on the application right now, which it says hello world. Then we're going to do act, and with act what we're going to do is we're going to use utilities so we're going to have output, let's say string output equals utilities period right line input text. And then what we're going to do is assert, and our assertion is going to be that dot r equal that our string input text and our output are the same. So I save this, and what I'm going to want to do now is I'm going to run my tests. So I'm going to go up here to the test menu, and I'm going to click on run all tests. And what we end up getting, you might have this test explorer come undocked or docked. You can have it both ways. And what it does is it just shows you that all of our tests have passed. Now, let's go back to our test right here, and I'm just going to show you what happens if let's say that we could have something like this. And maybe we'll do string expected equals hello. Oops. And let's just change this, and then we're going to run our test again, and you can see what happens if our tests don't work. And we can look at the test explorer, and we see that our right line test didn't work here. Now, if we go back to test utilities, what we're doing is arranging, acting, asserting. We're going to get our test to work, so here we can just copy this, and I'm going to paste this in here and save it. And what I'll do is I'm just going to run the test. And we can see what the check marks are. Test passed. And we can actually, if we come over to our utilities, oops, it'll show you that we have one test and it's passing. So we want to at least have at least one test. Sometimes you want to have more than one test depending on what's happening. So what I'm going to do here is we're just going to, actually to complete the program, we're going to do a console dot write line, and then we're going to improve this in the next version of the program, but it's going to print out the string text. And let's just run a test and run all the tests. And this isn't a really good test right now because we're really not checking the console output, but that's what we're going to cover in the next tutorial, because we want to get a little more into code and what we can do with C# and everything. So I'm just going to see that my tests are actually still continue to work after I made the modification. See, I got the thing to work, and then I added a little more code to do more, and my test continues to work, so I know that I'm doing what I need to do. Now, what I'm going to come over to do here is in Program and Console App, I'm going to right click on the Console App, and then I'm going to add a reference. And what I got to do is go Browse, and let me just go to my Smart Zambia, and I got to drill into Smart Zambia because we're going to have to go into Visual Studio, and then we got to go into Module 2A, and our console utilities are right here. So we want to go into bin because that's where the binaries are. And in the binary right now we just have debug, and we have console utilities, and we're adding that, and then we're going to click OK to add this as a dependency, so that what we can do now is we can go using console utilities, and then rather than having a console write line with hello world, what we're going to do, and actually we can sometimes with your test, it actually makes implementing things easier, because what we're going to do here, we're just going to take some of this code because we can use it in our actual implementation here, and I don't need a string expected, and I don't need this. So what I got to do is I have utilities, instantiate a new utilities class, string input text, that's what I want to print. Or we could say this is string to output I'm going to change this because and then actually we don't even need to return here. And what I'm going to do here is we're just going to, and we can actually, to slow down the test execution, we're doing a read key, console, read key. And I'm going to go up to here to build. Or to run, sorry, I'm going to run the console app. And we get a hello world, just like we did before. And that completes the app. And see, the advantage to this is that, and we'll see in the next unit or in the next module, because we're going to expand on this, but we're going to make it a lot better, that the basic idea is that we have this application that's the console app, and the console app really shouldn't do anything. We should really defer the actual program to our DLL libraries that we include with it. So really the console app is just like a shell that starts up the program, and then we work off of the DLLs that actually do the work. In the final program, what we're going to want to see is really where we just start up the utilities program, and or whatever class we end up with, and that does everything. We don't want to really have anything inside here other than just starting the whatever the entry point DLL is to start our program. All right, so what I'm going to do is just end this video here, and we're going to pick up with our next unit